In this video, we will take up the homework on 3D trigonometry word problems. The first question asks you to find the height of the antenna, and they give us a diagram. So my strategy was to solve for BC and then solve for DC. Now, because triangle ABC and triangle BCD are both right triangles, solving for BC and DC was pretty quick. You just got to use a correct trigonometric ratio. So yeah, that was question 1. Question 2, asking how tall is the tree. Now, once again, they give us a diagram, so it was pretty easy. I would argue like question 1 and 2 are very similar, except for the fact that the triangle along the ground for question 2 is not a right triangle, so you couldn't use SOHCAHTOA. So what I did was solve for one of the interior angles, angle ACB, and then I can use the sine law. And then I can solve for the height of the tree, which I've labeled as DC. All right, number 3 is where it gets a little interesting. Okay, after you read the question, you find out, or you're trying to find out how far is Neil from his car in a direct line. So mine is, I draw the line AD is what I'm looking for. Now, be careful. If you're doing a 40-degree turn, this is how it looks like. That means if it's a 40-degree turn, angle ABC is 140 degrees because those two angles are supplementary. Solve for angle ABC and then solve for the length of AC because you have two sides and a contained angle for triangle ABC. And once you have AC, you can solve for AD because triangle ADC is a right triangle. You can use a Pythagorean theorem actually. All right, question 4, beautiful question, no diagram. So for question 4, we were trying to find the height of the cliff, which I've labeled as DC. So triangle ABC is along the ground, which is not a right triangle, and triangle ACD is a right triangle. So number 4 is very, very similar to question 2. Yeah, it's basically the exact same strategy. All right, moving on. Question 5 here. What is the horizontal distance from the helicopter to the faster car? So I'm looking for EC. Okay, I'm looking for EC, the horizontal distance from the helicopter to the faster car. So what I did first was I solved for AB as well as AC. I solve for AB and AC, and if I do that, I can solve for BC because I have two sides and a contained angle for triangle ABC. So I use cosine law, I solve for BC. Now why do I want BC? Because once I find BE, I can solve for EC because BC minus BE will give me EC, which is what I'm looking for. So how do I find BE? Using the tangent ratio. And then I'm done. Okay, so question 6. With Romeo, Juliet, and Paris. So draw the diagram, beautiful. I'm going to use the tan ratio 2 times to isolate for, well, I'm going to solve for RB. Sorry, I'm going to solve for RB. I'm going to solve for BP using the tangent ratio. And I express RB in terms of JB and express BP in terms of JB. And then I see that the triangle RBP is a right triangle, so I can use a Pythagorean theorem. And then using some pretty interesting algebra, I can use a Pythagorean theorem, factor out JB squared, and then I can solve for JB, which is what I'm looking after. I'm looking for. I'm trying to find out how high is Juliet off the ground, which is about 35.9 meters. Okay, this one is interesting because of the algebra, but hopefully you can work it out and see how I did that. Okay, last one, question 7. We are trying to find the straight line distance from the helicopter to the sailboat. Helicopter to sailboat, so that's HS. So hopefully you got the right diagram. And once you have the right diagram, I can see that I want to solve for IS. IS is very powerful because it's part of both the triangles. It's part of triangle PIS and HIS. So anyways, solve for IS, and then you can solve for HS. So basically, sine law twice and you're done. Okay, so that's the homework for the 3D trig problems. Hopefully you didn't have too much trouble drawing the diagrams.